This problem is related to the concept of Coulomb's law and simple harmonic motion. Problem says two beads, each with charge q and mass m, are on a horizontal frictionless non-conducting circular hoop of radius r. So this is the circular hoop of radius r. So radius is given and there are two beads, one bead is here and another bead is here, and this hoop is also frictionless and non-conducting. This means charge cannot flow, and this is horizontal. This means this whole thing is kept in a horizontal plane. Now one of the beads is glued to the hoop at some point, while the other one performs a small oscillations about its equilibrium position along the hoop. So this bead is fixed, but this bead is doing SHM, that is simple harmonic motion. Then we have to find the square of angular frequency of a small oscillations is given by. So this means we have to find angular frequency and a square of angular frequency. So let us try to solve this problem. So this charge and this charge both are same. This is same type of charge. So positive positive or negative negative. Let us say these are positive positive and these two charges will repel each other, and this force is acting along this line, and this force will, magnitude of this force we can calculate using Coulomb's law, that is 1 by 4 pi epsilon naught r square times q1 q2. Now this is the force. This force will have two components, one component in this direction and another component in this direction. This force will be balanced by the normal reaction that is acting on this hoop, but this force that is in the tangential direction will try to make this bead move in this direction and do SHM. So this force is responsible for simple harmonic motion of the bead. Now to express this force in terms of radius r, we need to eliminate this small r, and for that I will use sine rule. That is, in this triangle, let's call this angle is phi and this angle is phi, then this angle will be pi minus 2 phi. So if I apply sine rule, I can say this distance r divided by sine phi is equals to r divided by this angle, that is sine of pi minus 2 phi. You may remember the sine rule, that is sine rule is this side divided by sine of this angle, this side divided by sine of this angle. Similarly, this side divided by sine of this angle. All these three terms are equal. Now sine of pi minus 2 phi is simply sine 2 phi, and sine 2 phi I can write 2 sine phi times cos phi. So sine phi cancels. So now I can write r equals to 2 cos phi times r, that is a small r equals to 2r cos phi. So now I can replace this r here. So force will be the same thing, only thing is r square will become 4r square cos square phi. So now I know the magnitude of this force. I can calculate force towards the mean position, because this is the mean position, or you can say force in the tangential direction. So in the tangential direction, force I will have, so this is force and this angle is phi, so this direction f cos phi, and in this direction I will have f sin phi. So component of force in tangential direction will be f sin phi, and f is this. So this multiplied by sin phi. Now see, we have phi angle, but this is making SHM and this angle is theta. So we have to somehow relate theta and phi, and this can easily be done because in this triangle this is an exterior angle. So exterior angle is sum of two opposite interior angles, that is 2 phi. So theta equals to 2 phi. This means phi is equals to theta by 2, because I have to express this equation in terms of theta. So let us write. So this force is, so I have F sin phi is this, and then I can write phi is equals to theta by 2. So this is 4r square cos square theta by 2, and this will be sin theta by 2. So the force in the tangential direction is this one. Now we have to make approximation, that is theta is very small, because this is doing SHM and this is angular amplitude, this is very small. This means cos theta will be 1 and sin theta by 2 will be simply equals to theta by 2. So whenever you have theta small, then cos theta is equals to 1 and sin theta is equals to theta. So this is the approximation I am making. Now we can simplify, so this becomes 4 into 4 into 2, that is 32 pi epsilon naught, and this is r square, and here I will have theta. So this is force in the tangential direction. Now I can write Newton's second law. Force in the tangential direction is equals to mass into acceleration in the tangential direction. So this is the force, that this force, and this is mass times acceleration. Now 2-3 points is important. This force tries to decrease the theta. So that's why we have to put a negative sign, because this is not in the increasing direction of theta. This force is in the decreasing direction of theta, and that's why we have to put a negative sign. Mass times acceleration. Tangential acceleration is equals to radius times angular acceleration, that is d2 theta by dt square. So at is equals to r alpha. So I am using that formula here. Now if you simplify, so this becomes d2 theta by dt square, and this is equals to q1 q2, and negative sign is here, 32 pi epsilon naught r square and divided by m, and r square and this r becomes basically rq. So now this is a simple harmonic motion equation, that is d2 theta by dt square equals to minus omega square times theta. So this is my omega square. So this is basically a square of angular frequency. So now you can check, that is which option is correct, that is q square by 32m pi epsilon naught rq. So if you see the options, so this option, because this has 32 pi epsilon naught rqm, so option B in this case is correct option. So I hope you enjoyed this video, and if you like my videos, please share with your friends, like on my channel and subscribe to my channel, and I will see you in the next video. Thank you.